Today's problem was submitted by a viewer, and it says, if alpha and beta are the roots of the equation x squared minus 2x plus 2 equals 0, what is the smallest positive, what is the smallest positive integer n such that alpha over beta to the power of n is equal to 1? Okay, well, I think what I'll start with is just compute the two roots to this equation. And then, yeah, just substitute in this equation and see if I can solve for n. It's a little interesting, though, that we have alpha over beta, the n equals 1, but it doesn't say if alpha, which root is alpha, which root is beta. So I wonder if the two roots will end up being, well, we'll see. Let's just figure it out. Okay, so looks like the two roots are complex. I wonder, will they then have the same two complex roots of a quadratic polynomial with real coefficients? They have to have the same modulus. So it won't matter which one we choose to be alpha and which one we choose to be beta. Let me make sure I did this right. I've been making a lot of simple arithmetic mistakes recently, so I'm trying to cut back on those. Okay, so negative b plus or minus the square root of b squared minus 4 ac. Okay, so we'll say alpha is equal to 2 plus, this will be root negative 4 over 2. And so beta is 2 minus the root of negative 4 over 2. But this alpha is, of course, 2 plus 2i over 2, which is equal to 1 plus I. And this will be equal to 1 minus I. Okay. And now I think converting these to radial coordinates is probably the best, because we're going to have alpha divided by beta raised to a power. It's easy to raise things to a power when they have the same, when things are written in polar coordinates. So alpha is root 2 times e to the I pi over 4, and beta is root 2 e to the negative I pi over 4. We can see that just by drawing Cartesian plane. We have 1 and I and negative I like this, so those are the two numbers. The modulus is clearly root 2 because that's a distance of 1, that's a distance of 1. And this angle, that angle is pi, so this is pi over 4. Okay, so alpha divided by beta is going to be e to the I times pi over 2. And we want the smallest positive integer. So this number, alpha over beta is that number there. So if we raise that to the power of 1, raise that to the power of 1, 2, 3, 4, we get 1. So alpha over beta to the 4 is equal to e to the 2 pi I, which is equal to 1. So my answer is that n equals equal to 4 is the smallest positive integer, such that the roots of these polynomials raised to the n is equal to 1. And we can see if we interchanged alpha and beta, if we instead wrote beta divided by alpha, because there's nothing saying that this root should be alpha and this one should be beta. I could have labeled them the other way around. The answer would still be 4, because then in that case, the number we get here is e to the negative I pi over 2, which is this number here, and that number raised to the 1, 2, 3, 4 also gives 1. So it doesn't matter which way you label these two roots, the answer is still going to be 4. Yeah, nice little problem. Testing whether you're comfortable with complex numbers, I guess. And yeah, I think converting into polar coordinates is the most straightforward way to handle this, these exponents. Thanks for the submission. Thanks for watching.